This is a video I've wanted to make for a while. I've kind of touched on some of the things I'd like to talk about in my other videos, but I haven't made a dedicated video to this alone. I want to talk about DeLorean ignition and weaknesses that are endemic to DeLorean ignition, the stock ignition setup. And I haven't thought this video all the way through. I'm kind of making it up as I go along. But what prompted it? There's an owner whose engine won't start. And it won't even start with ether sprayed into the intake manifold. Actually, I think he's using carb cleaner, but it should do something with a combustible aerosol sprayed into the intake. Bare minimum, the engine, coughs and burps. And his is doing nothing, just cranking and cranking and cranking and cranking. And what he has done is he's pulled the spark plug out and laid it on the engine and watched for a spark as the engine is rotating. Which is all fine and good. That's kind of an old-fashioned ignition test. You'll see old heads do it all the time. The lawnmower won't start. They'll pull the spark plug out and lay it on top of the lawnmower and see if it sparks or whatever. But it's not definitive. Okay, it should indicate that the breaker points are working, or the ignition module, if you have electronic ignition, the distributor pickup, if you have electronic ignition. If the spark plug is firing, just laying on top of the engine, that should indicate that the triggering mechanism that turns the coil on and off is operating properly. But it doesn't really tell you much more than that. And in his case, what he's reporting is a, quote, bright yellow spark. And that raised red flags for me immediately. Because yellow is a low voltage spark. The temperature of the spark is physically lower than what you want. You want blue to white. That's a much higher temperature spark, which would be a much higher voltage spark. So if he's getting a yellow spark, that would indicate that the voltage of the spark itself is inadequate. And even more so, the atmospheric pressure right now is like 14.7 psi, I think. Well, the pressure inside the combustion chamber is significantly higher. I think on a DeLorean it's going to be, somewhere in the 140 psi range. So you might be able to make a spark at 14.7 psi that you are not able to make in the higher pressure environment of the combustion chamber. So the old-fashioned spark plug laying on top of the engine is what it is, but it isn't what it isn't. And I've got a video on YouTube that shows a bunch of diagnoses that you can make to try to verify that your system's operating normally. But in this video, I'm going to just talk about all the resistances that the stock ignition system throws up to making a decent spark. And it really doesn't take a whole lot to upset the stock ignition apple cart. Let's start with the coil. Okay, this is the ignition coil. This is what generates the high voltage secondary ignition that jumps the spark plug gap. This is a factory ignition coil. Okay, this is what the car would have been built with. I don't run the factory ignition. I run high energy ignition, so you can see back there, I've got a Protronics coil. And the big difference between this coil and my coil is the capacity of the coil to generate a high voltage spark. My Protronics coil can generate a much higher voltage spark than this coil can generate. And the way you know that is you just measure the resistance of the windings inside the coil. This coil measures about 0.5 to 0.7 ohms internally, whereas my Protronics coil is 1.5 ohms internally. So assuming that the copper wires are comparable within the two of them, my Protronics coil has about 3 times as many windings as the Bosch coil has. And that is why my Protronics coil is rated for 45,000 volts. And this coil here, I believe, is rated somewhere like 12 to 15,000 volts. Now, it does not mean that either of these two coils is necessarily going to produce that much voltage. That's just what it's capable of producing. But the way the coil works is it's a ratio, of what is fed into the coil. Depending on how much voltage is fed into the coil, that'll determine how much secondary voltage is created. So if you do not have adequate voltage going into the coil, you're going to get much less voltage being created on the secondary side, because it's a ratio. It's like a step-up transformer. So the first thing to be aware of is that the Bosch coil that these cars were built with produces less voltage than most other cars that were for sale in 1981. This coil cannot produce as much voltage as a 1981 Ford, 1981 Chevy, God forbid, a 1981 Mopar. So from the very get-go, you're going to be somewhat hobbled. The next thing I want to talk about is rotor buttons inside the distributor. Not all rotor buttons are created equal. This is a genuine Bosch, made in Germany rotor button. You know that because it says Bosch, made in Germany on the underside there. This is a made in Italy rotor button. I don't know from whence. And then, where was this rotor button made? I have no idea. There's no manufacturer markings, no country of origin, no nothing. Now, this is where things get interesting. This potting material that you see right here, you see you've got the center conductor, then you have the blade that goes from terminal to terminal on the distributor cap. There is not a connection, contiguous connection between these two terminals like you would get on a Ford or a Chevy or, God forbid, a Mopar. I always thought there was a resistor. Okay, from here to here should be about 5,000 ohms of resistance. And I always thought there was a resistor buried underneath this potting material. That is not the case. This potting material itself is the resistor. Okay? Electricity is conducted through this material, whatever this material is, and from here to here is about 5,000 ohms of resistance, which is bonkers. In fact, after this segment, I will splice in a piece of a video that shows my rotor button is 0 ohms of resistance. I dremeled out all this potting material and actually soldered a wire from here to here, a little piece of Romex. So I have a 0 ohm rotor button in my distributor, but most factory DeLoreans will have 5,000 ohms of resistance, okay? So after you leave the coil and go to the distributor, before you go out to the spark plug, you're having to fight 5,000 ohms of resistance. Now let me show you this. This is fun. Okay. Here's Mr. Bosch rotor button, and he is 5,100 ohms of resistance. 5,150 ohms of resistance, which is about typical. Let's try Mr. Brand X rotor button. Let's see how much resistance Mr. Brand X has. 7,660 ohms. This rotor button has 50% more resistance than this rotor button does. So in an ignition system, this rotor button would cut down the spark that's going to your spark plug 50% more than this rotor button would. That's not good. As mentioned, my rotor button has been modified from a stock configuration. I have a solid piece of 12 gauge Romex soldered inside mine, and I've got some video clips showing how I did that, so I'll splice those in here. Now, as I've already discussed, Bosch rotor buttons are different from normal rotor buttons. This is a Ford DuraSpark, this is Ford TFI, both of which are 0 ohms resistance between the center of the distributor cap and the blade on the rotor button. A Bosch rotor button is 5,000 ohms resistance from the center of the distributor cap to the blade. So I always assumed that buried underneath this potting material was a resistor. But I just routed out a Bosch rotor button here, and there was nothing buried underneath the potting material. No wire, no electronic component, no nothing. It was just powder that came out of this. So I have to assume that that powder itself was electrically conductive. The potting material is not. This potting material is not electrically conductive. At least not just touching my probes to the surface of it. So something in the powder that came out of this rotor button was electrically conductive. It was not a wire. It was not an electronic component of any sort. And then the Bosch button, I mean, I dug all the way up under the central conductor. I mean, I've dug all through here, and there was nothing inside the Bosch button. And this is what comes out, is this white powder. I hope it's not carcinogenic. So there must be something in this white powder that is electrically conductive, because that's all you get out of a Bosch rotor button. There is nothing else inside here but whatever comes out as the white powder. Alright, I just soldered a piece of 12 gauge Romex into this rotor button. Okay, here are the two rotor buttons, potted and ready for service. As we've already discussed, a stock rotor button is about 5,000 ohms internal resistance from the center conductor to the blade. This is a 40,000 K setting, so that's 5,000 ohms through the rotor button. If you compare that to a domestic rotor button, this is a Ford DuraSpark, it has no internal resistance between the center conductor and the blade. It's metal the whole way. And now these rotor buttons emulate that DuraSpark button. They have no resistance between the center conductor and the blade. So now these rotor buttons emulate a Ford DuraSpark rotor button, not a stock rotor button. The PRV is not the only engine that has this funny 5,000 ohm rotor button. It seems to be standard Bosch practice to do that. And if you Google melted Bosch rotor button, you will get all kinds of reports from Mercedes owners and Volvo owners and all kinds of people that have had catastrophic failures of their Bosch rotor buttons. And these are just some of the images that I've captured off of the internet of these melted Bosch rotor buttons. And that is the reason why I modified mine to be a 0 ohm rotor button. Now let's talk distributor caps. The PRV distributor cap is fairly traditional, other than the weird terminal spacing. But a lot of owners don't seem to be aware that there is a spring-loaded contact in the center of the distributor cap, which is fairly standard. I think most distributor caps have this center conductor, center terminal spring-loaded. This is where voltage is fed in from the coil, and then that's what makes contact with the rotor button. And if anything happens to this center conductor here, you will not have good contact between your rotor button and going out to the terminals, to the spark plugs. So you need to make sure that the center conductor is in good condition. Because I helped an owner one time whose center conductor was actually missing. I think he had the spring. I think the spring is what was actually making contact with the rotor button, but this conductor's made out of, I don't know, some sort of a carbon graphite type material. It's not metal. And so it is possible to chip and damage this conductor. It's unlike these, which are made out of brass. This is not made out of brass. This is some sort of a graphite type material. So you need to make sure that your center conductor is in good condition. The fella that I helped, he was able to get the engine to start sometimes, but he never could rev it. The instant he went to try to rev it, it would die. And there's a guy on YouTube who calls himself the Car Wizard. His name's David Long. And he had a Volvo in his shop recently with the same problem. That center conductor was broken. So that's why his Volvo, he could get the Volvo to kind of run, but it just didn't run well. And that was his problem. So you need to make sure that the center conductor is in good condition on your distributor cap. And then the other thing is just general build quality. Bosch, you cannot get these made in Germany Bosch distributor caps anymore. Okay, if you've got one of these, keep it. Don't throw it away. Let's talk about the spark plugs themselves. A lot of people do not realize that there is resistance inside the spark plug. About 5,000 ohms of resistance inside the spark plug. There's an actual resistor. Underneath this terminal, there's a little resistor, and then the conductor continues through the spark plug. And they do that for RFI, radio interference. But if you measure a spark plug through the plug itself, this plug here is about 4,500 ohms of resistance, which is pretty typical. But what that means is that between the 5,000 ohms in the rotor button, the 4,000 to 5,000 ohms in the spark plug itself, and then however much resistance you have in your spark plug wires. These are low resistance spark plug wires, but factory spark plug wires like bougie cords or Bosch's are going to be somewhere in the 1,000 ohm, 500 to 1,000 ohms per wire. So altogether, under the best of circumstances, you are looking at 10 to 11,000 ohms of resistance between the ignition coil and the eventual spark that you create. So that is the endemic weakness that is built into the DeLorean ignition system, is all of this resistance that you're having to fight against. So now let's talk voltages. This is the resistor grid that the car was built with. Ordinarily it's mounted to this bracketry that's all the way across the back of the engine compartment. And what that resistor grid does is it reduces the voltage going into the ignition coil. Takes it from battery to charging system voltage, somewhere between 12 and 13.5 volts, and basically cuts it in half. Stock DeLorean is going to have somewhere between 6 and 8 volts going into its ignition coil. And as we've already discussed, the ignition coil itself has fewer windings, so it is less able to step up whatever is fed into it because it has fewer windings. The rotor button, you have 5,000 ohms of resistance passing through the rotor button that you won't find on a Ford or a Chevy. Of course, everybody has resistance in the spark plugs. But it was so bad that the cars would not start reliably. So what DeLorean did in their infinite wisdom was they rigged up this relay that ordinarily sits right here. And you have to use a relay, otherwise you cannot, even though the wiring diagram shows the resistor grid attached directly to the starter motor, if you did that, the starter motor would spin whenever ignition was on. This relay is not shown on the wiring diagram. The official DeLorean wiring diagram doesn't have the relay. This has got to be an 11th hour piece of engineering. But what that will do is bypass one of these two resistors, giving you somewhere between 8 and 10 volts into the coil, which then gives you a fighting chance of starting your engine. Which brings me to a diagnosis technique I haven't shown yet, but this is the jump start post. And this is connected directly to the electrical system. So right now my jump start post has battery voltage on it. So if I were to attach a wire to the jump start post and then attach it to the positive side of my coil, there's a little plus sign on the positive side of the coil. I am now feeding full battery voltage into my coil. Okay. So, if my engine wasn't starting before, but now it does start, what that means is there was a problem potentially with my bypass, or I could be having problems elsewhere in the ignition system. But one of your diagnosis techniques is to attach a wire to the jump start post and then attach that to the positive, look for the plus sign, the positive terminal of your coil, and then see if the engine starts. And so that's the situation that we find ourselves in. DeLorean ignition, factory spec ignition, even when it's operating properly, is significantly lower voltage, not only than Ford and General Motors, 1981 Ford, 1981 General Motors, but it's going to be weaker than any of the Japanese imports. Toyota, Datsun, Mazda, Honda. If you look at the spark plug gap, you have to remember the spark plug gap acts as a rudimentary voltage regulator. However much voltage it takes to jump the gap on the spark plug, that is the most that the coil will ever discharge. Even if it's capable of discharging more, once it's jumped the gap, it's like closing a circuit. That's it. That's the most it'll discharge. And if you look at any 1981 vehicle across the board, they are going to have spark plug gaps that are going to be anywhere from something in the 0.03s all the way up to about 0.05 to 0.06. You know, twice the DeLorean spark plug gap. And what that indicates, obviously, is that these other vehicles have ignition systems that are capable of jumping those much wider gaps. For example, on my car, I run a 0.045 inch plug gap, but I'm, of course, not running factory ignition. I'm running high energy ignition. So, getting back to the owner whose engine won't start, I suspect that he is not making a spark in the high pressure environment of the combustion chamber. And that is why his engine will not start even with aerosols sprayed into the intake manifold. I mean, he's getting nothing. He's not getting a cough, a burp, a sputter, nothing. It just cranks and cranks and cranks and cranks, even with the aerosols. So I would recommend that he dig into his ignition system, and remembering that under the best of circumstances, his ignition system would be fairly weak. I think in his particular case, it is so weak that he is not making spark.